Hey you guys, this is Mr. Sal. We're going to start Module 3 with interpreting graphs and charts. We're going to look at all different types of graphs and charts. So thanks for watching. Don't forget to like and subscribe and comment below on what you thought about the lesson. These are just different types of graphs, and it tells us when to use these in general. All right, they're more recommendations than anything. So if you're planning on using some kind of categorical data, then a bar graph would work, okay? Right, you guys have seen these before where, they compare populations of countries and they got a big old bar next to them or something like that. And then you look at the bar and they're really colorful, which makes them slightly attractive, but it's math, so it's still kind of ugly. But in any case, well, I don't think we deal a lot with box plots. Circle graphs are also known as pie graphs. We also don't deal a lot with double bar graphs, but it's just comparing two things in one graph. Like you could compare population at the same time that you can compare, what else do people compare? Square mileage, all right? Or land mass, whatever, okay? Histograms, these ones are bar graphs, but they generally deal with intervals, like we've seen. So you could compare the height of people who are between the ages of 5 and 10, and then 11 and 15, and so forth, all right? And that would be in intervals as we go. Line plots generally have to do with some kind of number line or time, usually time, all right? I don't know. Some people use line plots with stocks, but as far as I know, successful ones don't. Now, not on this list is a pictograph, which actually, as math people, we kind of hate. We kind of hate math. Not math, but, well, we do hate math, right? But pictographs, yeah, thanks. Yeah, okay. Here's the problem with pictographs is you got some kind of graph like this, right? So we got two axes, and they could represent some things, like, this one could be even categorical, like, we'll say votes. So if you guys are going into some kind of politics or something like this, you could use this if you wanted to trick a lot of people, okay? Now I point that out because pictographs specifically are generally very, very manipulative. Here's why. All right, so we could say that this is 25 and this is in percentage. So you could even show the percentage right there. I need more space. There we go. And then up here, this is 50%. So, maybe even if they're honest enough to show that the axes have the same scale, then that's great, all right? Well, in terms of votes, maybe this person, right, they have 25% of the votes, so they got, just to represent that, we would use a very small circle, or if you wanted to really emphasize it, man, they only have a line's worth of votes. And then for 50%, it's like, whoa, man, that thing is humongous, okay? But it's not based on the size of the picture, it's based on height right there. You see how that's kind of manipulated right there? Because how often do people really look at the percentages? Maybe rarely, okay? So be careful, especially when people start presenting this data in this way, because chances are they may want you to think a very specific type of way. This is an example of a pictograph. Now this one isn't emphasized as badly, and it's, it kind of represents it pretty well. But it's really just a bar graph that they've chosen to show pictures of stuff with, and maybe you like the stuff that they're showing, like chocolate bars, okay? Right? We like chocolate bars, and again, you see the manipulative part of that, because what do you think of when you think of chocolate? Happiness, okay? So, well, maybe we should do that more in math, just show pictures of chocolate bars all the time. Let's read the problem. Colleen, or is it choline? Whatever. Observed a candy store and counted the number of bars of chocolate sold. Categorized into milk chocolate, dark chocolate, white chocolate, chocolate with peanuts, chocolate with almonds, chocolate with pretzels and mint chocolate. She drew this pictograph. Very nice. How many chocolate with pretzel bars were sold? So on this one, it's just a matter of identifying this. These are all chocolate bars, and that's nice. It's not milk chocolate. It's not dark chocolate. It's not white chocolate. It's not chocolate with peanuts. It's not chocolate with almonds. It is, however, chocolate with pretzels. So how many bars were sold? 1, 2, 3, 4, 5. 5. We should label this. That's a lot less writing than writing chocolate bars. 5 chocolate bars with pretzels. Bam. Let's make it really difficult. How many milk chocolate bars were sold? That's kind of small there, right? You got to count them. Be careful. Oh, we want that there, though. 1. Oh, this should be working. What the heck? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is that what you guys got? That's what I got. So we're good. Line graphs can also be extremely manipulative if the scale of the axis is changed. Now, just so we understand this a little bit, because we're going to see this a lot later, this horizontal axis is called the x-axis, and the vertical axis is called the y-axis. Now, we didn't have to label those, but just so we understand it, we may refer to these more specifically as x and y-axis later on. Now, the x-axis is represented by years, and the y-axis is represented by population and peoples. Okay. Maybe this was in thousands or hundreds of thousands or something like that, but we don't really care about that right now because this is all the information that we have. The population of a small village is shown below. What was the population in 1850? Okay. Well, 1850 is not shown specifically on the graph. So we've got to look at 1840 and 1860 because 1850 is right in the middle of that. So 1850 would be right here. And the point that corresponds with 1850 is on this line right here at 300. So the population would have been 300, but don't forget to label that in people. Same graph, I think. What is the trend of the population? Well, this one's, I don't know. It can be described several different ways, but we can see it kind of go up and then it comes down, but the low here is higher than the previous low. Okay. Also, after that, it continues to increase and increase. And this new high, we'll do a different color there. This new high is bigger than that old high right there. Now, it does drop down, but again, we're looking at a low point here. And so the lows are getting higher, higher. And the highs also, right, because this is a high kind of, are also increasing. So since both the highs and the lows are increasing, this one is, the trend is, I'll just put up. The pie chart below shows a company's expenditures in the last quarter. In what category was the least amount of money spent? Okay. This one has, this whole section right here is technology. That's the biggest portion, so it's not that one. And then we got supplies. Yeah, I'm moving this down, right? That one's bigger than these other two. So we just have these two split right here, down that point, line, whatever. It appears to me that this one is bigger than this other slice, so I'm going to say that this one is the smallest for the least amount of money. So the answer to this one is travel. Now this one is a histogram because it is showing at the bottom of this graph these intervals. Okay, so we're looking at heights of soccer players, semi-professional soccer players, between 60 and 63 inches, and then 63 to 66 inches, 66 to 69 inches, 69 to 72 inches, and 72 to 75 inches. Okay, how many semi-professional soccer players in the sample have heights in this interval 69 to 72 inches? Okay. It's this one right here. So we're just looking only at this bar right here, okay? So this bar, it's a little bit higher than this line right here, which corresponds with 25. Well, it doesn't go that much higher. So it appears that it's only one player more than that, which appears to be 26. 26 soccer players. I'm just going to put players on that. Now, could this be 27? I don't know. Maybe. I mean, it's not really that specific. A 27, I would assume, just be a little bit higher. Okay. Amy categorized her spending for this month into 4 categories: rent, food, fun, and other. The percents she spent in each category are pictured here. If Amy spent a total of $2,900 this month, how much did she spend on rent? Okay. Rent in this case is this portion. Now we're not asking you to find any angles or anything like that. We're just looking at the percentage at 30%, right? So this is a percent proportion. So I got 100 right here. This specifically is at 30%. The total amount that she spent in the month, though, is all of it, which means that's going to be the denominator, because always part over the whole. So I got 2,900 right here. And we want to find whatever that part is. Okay. Now, once again, this 100 really represents 100%, and 100% of her spending is $2,900. So that just sets this up to solve. I got 30 times 2,900, and this would equal the other cross, 100 times x. So I'll divide both sides by 100, and that would give us the x, which is the amount that she spent on rent, at $870. Now again, if you want to be more specific and put that is for rent, then that's fine. You could. Kara categorized her spending for this month into 4 categories: rent, food, fun, and other. The amounts she spent in each category are pictured here. What percent of her total spending did she spend on rent? Okay. Now this one tells us how much she spent on rent, instead of us trying to figure out how much she spent on rent. So the percentage on this one is what we're trying to find. So in the percent proportion, we don't know what the percentage is. Okay. However, we can see that the amount of rent that she did spend is $389. Now, you may think that we have an unknown here as well. However, we can find out what that value is by taking all the values and adding them together. So we got food at $311. We got the rent at $389. And other was at $467, and fun for $233. We're just going to add these together. So as a total, money that she spent, or 100% of the money she spent, was $1,400. So that's going to be our whole value. And again, we're just going to solve this the same way. Cross multiplication. 1,400 times x equals 389 times 100. So 389, 38,900. There we go. Then we'll divide both sides by 1,400. And we see the amount of money that she spent percentage-wise on rent. But this one told us to round to the nearest whole percent, so we'll just say 28%. The bar graph below shows the percentage of students who received each letter grade on their last English paper. The class contained 60 students. What number of students earned a C or better on their paper? So we're looking at the C grade, which would be represented by this bar. because this is a bar graph, they just pushed them together. It's kind of unusual to see bar graphs pushed together like this, but this still works. And we can see that the top of this corresponds with this 30% over here. So it's 30% of the class. So again, this sets up a percent proportion for us, which isn't too bad. We already know the percentage is at 30%. The whole class is 60 students. So that's not part of the class, it's the whole class. And we got to solve for x and then make it a different color. And once we figure out what x is, we'll know how much of the class got a C on that test. So let's start multiplying these then. 30 times 60 is 1,800. Some of you guys don't even need to go any further than that. That's okay. 100 times x is 100x. Then we'll divide both sides by 100. And we get x is 18. So 18 students got a C. Students. Oh, dang it. I read that wrong. My bad. It's or better. So we should have done the D grade, dang it. That's still not bad. All we got to do is change the 30 with 20 on that, which I'm going to do now. The reason why I'm doing 20 is because this would be the number of students that got less than a C. So I would just subtract this from the 60 students. And that will tell me how many students got a C or better. Okay. Well, multiplying these out, you'd get 1,200 equals 100x, so divide by 100. That means that this represents 12 students right here. I did skip a couple steps, sorry. 12 students, and since the rest of this stuff, well, all of it represents the whole class, then the rest of it would be 60 students minus the 12 that got less than a C, and we get 48 students. That's all we really wanted. That's okay, it's good practice anyways. But this is the final answer we really wanted. Without setting it up that way. Another way to do this is you could figure out how many students were in each category. So right now, we did 12 right there, and we know there was 18 from this one. So you could have done the B at 20 students, and then the A also, since it's the same as the C, that's 18 more students. And then the 15 also, you'd get 12. If you add all these together, you should get 48 also. Now you'd have to set that proportion up. You'd have to set this proportion up 3 times and then add them. Or you can just say, well, in percentages, A was at 30%, B is at 20%, and C is also at 30%. So we could have just added those percentages together and gotten 80% of the students, and then used that in the percent proportion. So 80 over 100 equals x over 60, and this would also have given you the answer at 48 students. Now again, that's just a matter of preference.